significant figures. Significant figures is an important concept in chemistry because it determines the value of our measurement. We get significant figures because we measure things. And how we measure things determines how many significant figures we have in a measurement. So for example, here we have some liquid in a graduated cylinder. And if we looked at this liquid, we would see that there are some numbers here. Here's a 4, there's a 5, in between are these little lines. So we see that if we look at them, there's 10 of them. So each line is a tenth. And we can also estimate between lines. If we look here at this space, looks like the meniscus here is kind of in the middle between the big line here, which is at 5, and the next one 6. So if we were to estimate here, we would say that maybe this measurement is about 4.56 or so. Yes? So we say that there are 1, 2, 3 things that we've measured. We measured this in the ones place, we measured these tenths, and then we've estimated between the tenths to get the hundredths place. All of them are things that we've measured. If they're things that we measured, we say that they are significant. We want to work a little bit more here on using significant figures in chemistry. So, how do we know which of these digits in a number, which figures in a number are significant? Well, there's some clues here. If the digits of the figures in a number are not 0, it implies that somebody measured them. 1s and 5s. Somebody had to measure the 1 and the 5. So we say those things were measured, so there's 2 significant figures there. Now, if there's a 0 between 2 non-zero numbers, it also kind of implies that it was measured. We were able to measure to the hundredths and to the ones. That sort of implies that we also measured to the tenths. Okay? And so we'd say that all 3 of these numbers, the 1, the 0, and the 5, are all significant figures here. So if you got a 0 in between non-zeros, they count as significant figures as well. Now here we have some things going on here. Let's check out these. Certainly the 1 and the 5 are significant here. This guy and this guy, because they're not zeros. We'd also say, well, the 0 between the 1 and the 5 is significant because of rule number 2 up here, which says that things between non-zero numbers are significant. But what about this 0 over there? Okay. Well, these we call them zeros to the right side of the decimal are there because it implies that you measured something out to this place. Otherwise, you would just cut it off there and just write 0.00105. But because somebody wrote down a 0 here, and it's to the right of the decimal, so it wouldn't have to be there to make the number, then we say it's probably a significant measurement. Somebody measured that 0 to that place. So then we would say that these 4 numbers here are all significant. Now what about these other zeros over there? Well, these we don't know about. We don't know if somebody measured to the tenths or the ones or here, okay? Because we could have had something, some measuring stick that was on this scale here, and those kind of things would be too big to even be measured. So we can't say anything about these, what we call leading zeros. And in fact, these leading zeros might be there just to hold the decimal there. We don't know. We could write this number here in scientific notation like this, and then it becomes more clear as to what the significant digits are. The 1, the 5, the 0 between the 1 and the 5, and this 0 because we wouldn't have to write him unless we measured him. So here we have 4 significant figures. So if in doubt, it's good to take floating point and put it into scientific notation. And that can help clear up some questions about which zeros might be significant. Alright, now trailing zeros may or may not be significant. If the trailing zero is, like we said, to the right of the decimal, then it's going to be significant. If it's on the other side of the decimal, like 150, you're not sure. The zero here might be there just to hold the decimal point there. Okay, so we don't know. So zeros that are trailing zeros, and they're to the left of the decimal, we don't know about them. We could take 150 and write it as 1.5 times 10 to the minus 2, and we wouldn't need that zero. So this zero over here is just a placeholder to fix the decimal. So he might not be something that was measured. If we don't know he was measured, we can't assume that he was significant. We can't assume that he's an unmeasured number. So we say we have only here 2 significant figures. If it had 3 significant figures, we could write it like this. And now this 0, because he's on the right side of the decimal, that 0 would be significant. And it wouldn't be ambiguous as to his significance. It'd be clear, because he's to the right side of the decimal. So that's why it's always best to write things in scientific notation, so you don't have ambiguities like this. So how do you write everything in scientific notation? Well, again, go to your calculator, okay? Use the mode key, like we did before, for the units, and this time go over to exponential format. See that here, exponential format, and make sure yours is highlighting in scientific notation. Also, it's helpful to lock your calculator in what we call approximation mode. Okay, so under exact or approximate, choose approximate because this will give you a decimal answer rather than something like pi. Pi may be good for the math people, but it's not so good for us in the sciences. So make these 2 adjustments on your calculator, and that should help clear up a few things as we go on. So here's some questions here. Ask yourself, determine the number of significant figures in a number. Pause the video here for a minute. Write on a piece of scratch paper how many sig figs you think there are in each of these numbers, and then we'll check you. Okay, all done? All right, let's check. All right, the first one we have 4 sig figs. 1, 2, 3, 4. The 0 here doesn't count because it's just a placeholder. Okay, it just holds the decimal in place. Next one, we have 5 sig figs because these zeros here are between non-zero numbers, so all 5 of those guys are significant. Here, this is kind of, well, I might say it's a trick question. Okay, we have an infinite number of sig figs here because we can say that 10 decimeters equals exactly 1 meter. This is a defined quantity, and so I say it has infinite sig figness to it. Just like there's exactly 12 inches in 1 foot, things like that. Now the one below it here, 1.00 times 10 to the 5th seconds, because these trailing zeros are to the right of the decimal and implies that we measured those things. So all 4 of those numbers are sig figs. And here, in this situation, all these zeros here are just placeholders. We could have written this as 2 times 10 to the minus, let's see, 1, 2, 3, 4. And then there'd just be 1 sig fig, because we wouldn't need to do anything else. And then lastly, this one here, we say it's ambiguous, because we don't know if we just measured the 10,000s, if we measured it to thousands or hundreds or whatever. We could have written 1.0000 times 10 to the 5th, which is the same as 10,000, and then we would know that all these guys are significant because they're to the right of the decimal and they must have been measured. But we don't know. So the best you can do is assume the worst. The worst is that there's just one sig fig here. Alright, now let's do some operations with sig figs. Hang on with me here just a little bit longer. See how this works. For multiplication, there are some rules that says for all the factors that you have, okay, choose the factor that has the least number of sig figs, and that's how many factors you can have in your product or quotient. In this one, the least number of sig figs is here, 3, so that's the best you can do. With addition, you say to yourself, well, what's my least precise unit of measure? If I take 5 here and add it to 2, you think it's a 7, but since we don't know what number goes in this place, we don't know if this really is 7 or not. So all this stuff over here is meaningless, so after we do the addition, we cut it off here to the least precise measurement of all the measurements that we're adding together. Now, if you have addition and multiplication together, the thing you want to do first is do this, add them together, and then go to the least precise position, which is going to be at the hundredths. See how many sig figs you have there. That will be the number of sig figs in this one factor. And then ask how many sig figs you have over there. Looks here like we'll have it. Ooh, well, I'm not sure. If we take 452.67 and subtract 0.33 here, these guys go away. So we're going to have 0.67 subtract 0.33, which is about point what? 3455. But the 55s are no good because we don't have anything out here. So we got 0.34, which is 2 sig figs. 2 sig figs here. Here's 4. Here's, ooh, wow, look at that, 6. So the least number is 2. So when we have our answer over here, the most sig figs we can have in our answer is going to be only 2. Okay. Here, multiplying, and then subtract it off. This is going to give us 2 sig figs, and then we do the math part there, or the addition part, and we'll see what we end up with. So here we go. Alright, here are the solutions. For the first one, we have 3 sig figs. 3 sig figs. Here we cut these guys all off there, so we round off to the 9. Carry them along as we do the math, but then round off to the least precise place. Okay, here we end up with 2 sig figs, because in here we only had 2 sig figs, as we said earlier. Here when we did this math, this is going to give us 2 sig figs. It's going to be about half, so 7.4-ish or so. Subtract 8.02, okay, and you're going to get something like that. Okay, and it's going to be to the tenths, so there you get your answer in the tenths. All right, hope you're kind of following along with this and trying these things on your own, exploring some mastery chemistry examples and good stuff like that. So here's a clicker question for you, quick a minute, and we're going to go on to your quiz. Calculate the following with the correct number of sig figs. See if you can do this, and then we'll come back. Okay, you think you got it? All right. So the correct answer here is 2.2. Okay, note that we do the stuff in the parentheses here first. Okay, there you go. 1.42 subtract 1.08. This is going to give us 0.348, but only 2 of these numbers are significant. This is like a 3.5 is what you've got. So that's like a 0.35 up there on the top. You're dividing by something with 3 sig figs. Okay. So here you go, there and there. And that gives you this number, 1.208. But of course only 2 of them are significant there. You take that number here that you had, okay, multiply it by 2.83 times 0.36, and again these are 3 sig figs. Over there you only had 2, so the best you can get out of this is going to be 2 sig figs. Okay, so you have this guy, and this guy to choose from. They all could have been right depending on how many sig figs you have. Okay, this is the correct number of sig figs here.